Okay. Thank you for the introduction. Some of you may have already seen parts of this presentation in Vienna, but it is a bit an extension, and I think it's important to discuss this in this round here. This is a common effort from the Code AC team, that's why we have the complete group here as co-authors. So the discussion on how a PPP should behave regarding the geocenter is quite old. 20 years ago, in the same room, the IGS had a great debate on this, and in the recommendations, more or less the conclusion of the discussions are given that a PPP has to end for the user in coordinates in the ITRF period. The clock corrections have to be consistent to this. And there was another section that one has also to consider somehow the geocenter motion, because it's relevant for orbit determination. The satellites are used to flying around the current center of mass and not around a point that Zuher, Mattis, or who else has defined as the origin of a coordinate frame. So, there is, of course, a theory behind. Then when we apply this theory, we will see something a bit unexpected, but I have even an explanation for this surprise, and then some discussions at the end. So the theory, we have a point at the surface of the Earth that we want to describe with coordinates. These coordinates have to be in relative to origin that is stable in time, otherwise I get variations in the coordinates that just come from variations of the origin. So from this, it's a center of figure-based origin. So now if we have a satellite and we have a relation from the receiver to the satellite, and if the satellite positions are given also in the center of figure frame, then I can just interpolate without any force model between the positions. And the sampling in the SP3 file is exactly done in a way that it is possible. So, meaning the satellite positions have also be in the same frame as the station coordinates in the ITRF center of figure-based. That this is working. But if you do an orbit modeling, you have to switch to the center of mass frame, just for the reason what I explained to you before. And then this geocenter vector becomes into the game, the dislocation of the center of mass with respect to the center of figure. So in principle we need center of figure-based ITRF for station positions, for satellite positions, for interpolation, and only for the orbit integration we need a center of mass-based frame. And after the orbit integration we can switch back by applying the geocenter vector to the positions in the center of figure-based frame. This way, this terrestrial frame which is attached to the Earth is a temporary thing that doesn't need a real maintenance. It only appears in my solution. Okay, now let's test this theory in practice. We have processed 100 stations from the Code Rapid solution in the same way as we are doing our rapid processing. We have taken 10 days from the last year with big amplitudes in the geocenter motion model from the ITRF. ambiguities are resolved, a poor one-day solution, then 3 consecutive normal equations are stacked to a 3-day solution. Here we applied the datum definition with respect to IGS 20, and then we had more or less the geometry given, and then we did a back substitution to obtain the clock parameters for a PPB. So this was done 2 times. One, forcing the satellites to refer to the ITRF frame, and another time that they refer to the center of mass as it is provided by the center of mass model from the ITRF. So now when we compare the 2 obtained station coordinates, they differ by less than half a millimeter, because from the datum definition both are forced into the IGS 20. And surprisingly, the satellite positions are also identical when we transform them back. And the real surprise comes when you compare the satellite position in the terrestrial frame attached to the Earth, and there we have differences of half of a centimeter. And what we would expect is that if we just have this translation parameter added, that if I apply a translation, that it would absorb this geocenter vector again. But this seems not to be the case when I look at the transformation parameters. They are that near to 0 that it's much less than 10% of the geocenter vector that I have introduced. What did happen? We estimated also satellite clocks, by the way, and comparing the satellite clocks between the 2 solutions, this is one of them. The other, if we look at the differences, then we get about 10 nanoseconds different. This very nice periods in it. So these are 2 neighboring satellites from Galileo. If we add the 2 antipodal satellites, we have the same picture, but phase shifted by 180 degrees. So it seems that the geocenter vector that we have introduced are just ended up in the satellite clocks. And now let's take this difference of the satellite clocks and let's recover the geocenter vector from this, and exactly we get the same numbers. And you can even do the game and do this recovery system-wise. Then you have for x, y component high consistency between the 3 included GNSS. For Z there is some systematics, but this is also known that the Z geocenter translation component tells more something on orbit modeling than on real mass behavior. What does it mean? It means at the end that the satellites know by themselves where the geocenter is located, or the center of mass is located. And they go into this position. All differences, independent what we are doing for datum definition or trying some tricks to apply a center of mass correction, this is just ignored and pushed into the satellite clocks. So what we can do in that case, we should know where the satellites feel that the geocenter is located. And this we can get very simple by adding the translation vector in the solution. And this is the 3rd time when I went through this procedure. Now we have the difference between the estimated geocenter solution and the center of figure solution. The amplitudes are twice as big as before, and we see that we get back the geocenter that is estimated, the estimate from the station coordinates is recovered by the differences of the clocks. So what we can do now with this estimated geocenter vector, we can just take it. We have all the satellites and the stations now relative to this estimated center of mass. We can turn the story around for the satellite positions and subtract this. In this way we obtain some satellite positions with respect to the center of figure, and then we can add another center of mass correction that we believe that might be more appropriate than just this estimate. And then we can do the orbit modeling in that way. This works only if you don't estimate satellite clocks, but if you do just the pure orbit integration in this way. So that's why I have added few more steps in between obtaining geometry and the recovery of the satellite clocks. So we get the estimated center of mass for the satellite position, removing this estimated geocenter vector. We have the satellite positions in the center of figure frame. When we added again the ITRF center of mass correction, then we are in a defined geocenter. So if we look now only on the differences of the orbits just from the orbit integration, then we have differences between 1 and 5 millimeters in the first step, and 1 to 2 millimeters in the second step. Of course, the variations depend on the beta angle of the corresponding satellite. Yeah, why to do this when you have anyhow only the issue with LEOs? Because for the GNSS satellites you can more or less do whatever you want. With LEOs we have the issue that we can really estimate the satellite clock because the entire horizon is covered with observations. There we cannot cheat. With GNSS satellites we have only the 13-degree net angle with observations. But there's a very simple solution. If you have a geocenter vector that you can trust, then you apply this just to both the GNSS satellites and the LEO trajectory, and then you can use the same satellite clock corrections for PPP style LEO POD as you have obtained with respect to the center of figure. Yeah, I think the main message that I want to bring, we can really stay with the convention. With the PPP, you end up in a center of figure based ITRF realization.